Hey guys, section 3.2 notes. It's more on operations with polynomials. So in section 3.1, we had filled in this chart to this point. So might as well get this last line here. So we're going to put some add subtract problems on board here. I think this would be pretty obvious. If the operation is to multiply, and then multiply the coefficients, raised to a power means square, cube, raised to a fourth power, etc., etc. So that's the same thing. And if you're dividing, you divide. Big surprise. So if you're doing an add or subtract problem, well, gosh, no brainer, right? You're going to add, you're going to subtract. Now, as far as the exponents go, let's go ahead and do this first problem, and we'll come back and fill in that extra spot there. All right, problem number 1. I'm going to add some polynomials. And somewhere along the line, they would have taught you that you can only add like terms, and a like term is common exponents, common variables. So 2x squared, 1x squared. Well, 2 of something plus 1 of something, would that be 3 of something different, or would that be 3 of the same something? So if I got some x squareds and some more x squareds, I get a total of 3x squareds. So if I get a negative 4x and a positive 6x, so what do we do with coefficients? Well, we just add them. So negative 4 and 6 makes it positive 2. And if I'm adding up x's, and I end up with x's. And kind of a no-brainer here, right? If I'm going to add some numbers, just add them up. Positive 9, negative 13 makes negative 4. So if we add up some x squareds, we get x squared. So we add up some x's, we get x's. So therefore, we didn't do anything with the exponents. We didn't change them. Or they stay the same. All right, problem number 2, another addition problem. So basically all you have to do is go find the like terms. I get a negative 8 of this guy plus 1 of that guy. Add the coefficients. Leave the variable. Negative 3mn and negative 7mn. Total of negative 10. Now again, I'm just not going to change what follows. So I get an m and an n. So what do we do with the plus 5n? Well, there's no n's to add him to. Stuck with them. Can't get rid of them. So I'll just write them down. So can I add these guys together or not from here? Well, no. One's an m, one's an n, one's got an mn. So the only way I can rewrite or add them together is to be able to keep the same variable. And I can't keep the same variable if they're all different to start with. So that's it for that. Now the subtract problems can be a little tricky. Here's why. Let me go back up to one of these. This last problem we just did. Understood to be a 1 right there. And what would happen if you would distribute and multiply everything times 1? Nothing would happen. So that's why we get to ignore the parentheses on those. But if I were to take the time to put a negative 1 right there, and I distributed those two things, well, what's negative 1 times 6? Negative 6. But more importantly, what's negative 1 times negative 5? Well, a negative times a negative is a positive. So my advice to you would be to go ahead and rewrite it first. So the signs are just going to switch. Now if I put a positive 1 right there and distributed, nothing would happen. Times that guy, get the same thing. Times that guy, get the same thing. Now you could have done those with problems 1 and 2, but there aren't going to be any signs that switch, so there really isn't any point. So switch the signs, then combine them. 8 of these guys minus 6 of those guys would be 2 of the same thing. Negative 7 of these, positive 5 of these would make negative 2 of those. So in other words, the variable part, the exponents, don't change. All right, so same thing here on number 4. If I were to distribute with a positive 1, nothing would happen. But I'm going to take the time to rewrite it anyway, just because the second one's going to change. So for a subtract problem, subtract 17, sure. What happens if you subtract a negative? Well, if I subtract a negative, that's like distributing a negative sign. He's going to become positive. And subtract the 3r squared. So if you think about the sign switch, that was a positive 17, now he's negative. That was a minus 2xy, now he's positive. That was a plus 3r squared, now he's negative. And all we have to do is go and find like terms. 5r squared, and clear on the end here is a minus 3r squared. So 5 of those guys, minus 3 of those guys, 2 of those guys. I got a negative 10x and a positive 2x. If I combine the coefficients, I get negative 8. Whatever follows doesn't change. And I got a positive 12 and a minus 17 for a total of negative 5. And that's it. So really all you got to look out for on the addition subtraction ones is make sure you are switching the signs on the second one when doing a subtract problem. All right, here's some terminology, non-math. So if you read these two boxes down below, the definition of a polynomial is something where the exponent, oops, got to put this up a little higher, is no less than 1. So some of them are a little more obvious than others, and I'll give you my best advice for whether to write yes or no here in a minute. But negative 5 exponent, that's definitely yet less than 1. That makes that guy no. And I'll just cut to the chaser with a degree. If the answer is no, then we don't bother naming the degree. So we won't have to fill in that blank. So on the second one, I don't see any exponents that are smaller than 1. There's a 6. This is understood to be a 1 right there. It's not smaller than 1. So that's a yes. So we'll get to the degree here in a second on that. So here's my advice to you if you don't remember this. A square root symbol actually means that there's an exponent, and the exponent is understood to be 1/2. So any root, a cubed root, a fourth root, they're all fraction exponents, which are definitely less than 1, makes it a no. So rather than try to remember that, my advice to you would be this. If you see something funky, something strange, something weird happening to a variable, you're going to write no. Otherwise, you're going to write yes. So number 4, you might say, well, there's something strange happening. We've got a square root symbol, but the square root symbol is around the 5, not the variable. So there's a 9y to the 1 power. There's a y squared, so no exponents less than 1, nothing strange happening to the variables. So that makes it a yes. So on number 5, a little more straightforward. There's nothing strange happening, just a whole bunch of exponents, and none of them are less than 1, so that's a yes. Okay, now number 6, is it customary? Do you normally see a variable on the bottom of a fraction? And the answer to that is no. So this guy's going to be no, but here's why. So we did just talk about negative exponents in that previous section. If I were to rewrite the y back on top with a 3, it means it would have had to have been a negative exponent for me to move it back to the bottom in the first place. So can't divide by a variable because that's understood to be a negative exponent. And negative 1 is definitely less than 1, so that makes that guy no. So I wouldn't have to name the degree. Now the degree is pretty easy under one set of circumstances, not so much on the other one. So if you read this little spot right here, it says the degree of a polynomial with one variable is the highest exponent. So if you look at number 2, there's a bunch of a's. There's not b's, there's not c's, there's only one variable. So all we have to do is find the highest exponent, which in this case is an 8. And the degree is 8. On number 4, there's only y's. There's no z's, there's no w's, there's no x's. And the highest exponent I see is 2. So the degree is 2. But on number 5, there's more than one variable. There's a w and a v. So here's how you go about doing it. You're going to total up the exponents for each part. So the total of the exponents for that term is 5. That's understood to be an exponent of 1 right there. The total of the exponents for that term is 5. This guy has no exponents, so his total technically would be 0. And if we total these guys right here in the end, it's 6. So what's the highest total per term? That term was a total of 5. That was a total of 5. That one had none. And this guy right here is a total of 6. So the degree is 6. So that's easy enough to do, but it's a memory thing. You got to remember, if there's more than one variable, then I have to total them. All right, we'll pick up the rest here. We've got distributed property, FOIL problems, and box problems coming up in section 2. Thanks for watching.